Again, you're welcome. This is brought to you by a Will Bar. Don't forget, like, comment, share, subscribe. All right, so we'll continue from what we're looking at. This is another problem before us. This is in sets, and obviously we can see from these we have our intersection, we have our set difference, we have our union. Let's prove this. Let's write out this proof. Now, first, I will explain what we mean by set difference. Let's say we have set A and B. Of course, both are non-empty. We have two non-empty sets. Then A minus B is defined as A intersection B complement. So, simply put, they are all set of elements. They are actually that are present in A, but not in B. However, this is how to see it. So now let me start from left hand side. So from left hand side. So if I have A negative B A minus, let me call it minus, but mind you, set difference. It's not your typical subtraction. So we have that as, so I can write that as A intersection everything I have here, B intersection C, all complement. Now before I proceed, I will actually remind us of this. Perhaps you've come across this, which I believe you should, is what we call our De Morgan's law. What does our guy De Morgan says? He says that if I have two non-empty sets A and B, then A intersection B complement is equal to A complement union B complement. And vice versa. If I have A union B, all complements, same thing as A complement intersection B complement. Now take note of this because it comes very handy. Now I call this star. So that means from star, that is when I have A intersection B intersection C complement. If I take this first, so I have A intersection. Now I said this is nothing but B complement union C complement. Now what allows us to do that is that by De Morgan's law. So De Morgan's law allows us to do that. So this is what we call set difference derivation. So let's take note of those extra information. Now with this, I'm going to talk about distributive property. Let me write that correctly. Distributive property. Now what does that mean? Your intersection distributes over you. Now let me relate it in arithmetic. Remember, if I have 2 in bracket 5 plus 3, I can write this as 2 multiplying 5 plus 2 multiplying 3. This is distributive property. Now similarly in sets, we have that also applicable. So if we want to have this, I can write this as A intersection, just to see this, multiply this, so that A intersection B complement, then what you have in between is addition. So union A intersection C complement. So state it, this is by distributive property. It allows us to do that. Now recall what we define our set difference as. We said this is nothing but A, this union A, and this also complement as AC. So that is, recall, remember how we started? We started from this. So it implies that we have A, B, intersection C, nothing but A, symmetric difference B, set difference, no symmetric difference, set difference, union. So QED, just as required. So see in our next class. Thank you. Don't forget, like, subscribe, and share with friends.